Okay, good day. So today we're going to discuss about diesel cycle and dual cycle. So these two cycles are subsequent topics to the previously discussed Otto cycle, no, which is the basis for the gasoline engine. Now, diesel cycle is the basis for the diesel engine, which is widely used today, no, among cars which are larger than sedan, no. So sedan is kanang auto, no, like Vios, normal auto sedan na siya. Ababa na mga maabot na kag mga SUV or mga pickup. Those engines are particularly run by a diesel engine which utilizes this diesel cycle, no. And dual cycle is a combination of both diesel and gasoline cycle, no. The reason why uh, we study dual cycle is if ever there is a theoretical engine which capable of being fueled of certain fuel that is somewhere in between gasoline and diesel, no. So in order to optimize the heat addition to produce more power, we need both spark plug and compression combustion, no. So but dual cycle rarely occurs because it's very hard to find a fuel that could run in both scenarios, no, because typically diesel fuel uh, is very dangerous for spark plugs, no, because uh, it extinguishes the spark in the spark plug because it is an insulator, it is an oil, it doesn't dry that easily, so it would be very hard to operate diesel spark plug if there is a diesel fuel, no, it will not spark, of course. And if we also focus on the dual cycle, if we will remember the dual cycle both has a spark plug and combustion to through ignition, no, combustion through compression, but the hot gas is supplied with an air fuel mixture that therefore creates a combustion. So therefore the question really about the dual cycle is the type of fuel to be used. It's very tricky to have that. It's just a theoretical combination, an engine that is theoretically a combination of spark plug ignition and compression combustion cycle, no, or gasoline or diesel cycle. Now, since we already discussed with auto or gasoline cycle, we will now be going to discuss with diesel cycle, no. So we are going to talk about a standard diesel cycle. So air standard diesel cycle. So air standard diesel cycle is less efficient. So therefore, less efficient than standard. So meaning, ang gipanggamit ani nga during the combustion era, which air is the one that circulates throughout the cycle, no. It's the air standard auto cycle. So it is said that diesel cycle at the same RK, no, compression ratio, has lesser efficiency than gasoline engine. So what is the proof that diesel engine is less efficient than a gasoline engine? So if you look at the for the same RK, if you will look at the tambutso of the diesel car, no, it's very black compared to the tambutso of a gasoline engine, no, gasoline engine powered car. It's much more cleaner, much more uh, dili kay kakita og mga soot, no, or unborn carbon. Whereas in the diesel engine, you see a lot of this black substance, no, especially sticking at the exhaust pipe, that is unborn carbon. Therefore, by it indicates that there is less power produced because there are still carbon that is uncombusted, which is supposedly if combusted produces again power, no? But because diesel engine at the same compression ratio of an Otto cycle is lesser in efficiency, no? So that is why diesel engines are particularly in the sense have more unburned carbon monoxide, no? The black dark thick gas that comes out of the pipe, especially kung kanang magpremira ang diesel engine, no, it produces a thick black smoke. That if that is a thick black smoke, then therefore that is carbon monoxide. If there is black soot in the tailpipe, then that is unborn carbon. Those things are indication that imperfect combustion is occurring. And when there is imperfect combustion, there is lesser efficiency. Compared to a gasoline engine, if you will look at the tailpipe, it's much more cleaner. Therefore, most of the fuels are combusted, no? And produces water molecules, no? So that is why a very healthy engine sometimes produces these droplets of water at the tailpipe, no, during the combustion. And also gasoline engine like Bios, like Almira, like Wigo. So you cannot see smoke, no, in the car, especially when it is running. You don't see that much smoke. Unlike the diesel engine where it is very common sa mga POG kanang pasayro, very common there's black thick smoke uh, released at the tailpipe. So those are indications of unburned, while in the unburned fuels, while in the gasoline it's much more clearer. So therefore, what is the clear? Uh, why is it that it is clear? Because it is most of it are carbon dioxide, no? So carbon dioxide is colorless gas, is a colorless gas, therefore, which is an indication that the combustion occurring is much more efficient, no? Therefore, gasoline engine again at the same compression ratio, it has better efficiency compared to the diesel cycle, no? But only that, diesel cycle has its advantages because uh, diesel fuel is much more cheaper, and also it serves as a lubricating oil to the engine, which make the engine last, no, more for many years. Those two things are the pros and cons of the diesel engine and the gasoline engine. So diesel fuel is injected. So again, diesel fuel is fed through an injector, no? So long time ago, injector is only present in a diesel engine, no? But right now, injector technology is also used in a gasoline engine. So instead of a normal carburetor which mixes air and fuel mixture to be fed into the intake valve, now there is a an injector, no, at the intake valve, no, carburetor and then intake valve. So typically this creates a much more fuel efficient in terms of kilometers per liter, no, consume. So meaning mas taas ang karon ang mga cars karon, especially gasoline engine cars, no longer relying on the carburetor, therefore has much more larger uh, mileage, no, or sometimes the amount of kilometers per liter travel, no. So the value of that is higher, meaning for 1 liter maka-travel siya much more higher because of the fuel injection technology. Whereas in the diesel, in the old times, diesel is really injected, no, into the cylinder, okay, and ignition. So it creates an ignition is due to high temperature, due to high temp of compressed air. So if we will be going to draw a typical schematic representation of the diesel engine, it looks like this, no? So so pangalan ni, the device at the middle is the injector, no? So the injector is fed with fuel. So this is na the injector. So this is now the injector. So the injector is the one that is that will supply fuel to the compressed air. So here in the intake valve is where the air flows, and in the exhaust valve is where the exhaust exits, no? Ah. So therefore, when time wherein the piston is moves up for the compression stroke, this creates a huge amount of hot gas that is compressed, no? And then after it is compressed, it sprays ay air mo so there is air coming in. So this is air, then this is the fuel. Fuel is sprayed, no? So there is air and there is fuel, therefore plus there is heat. So fuel plus heat plus air equals combustion. So therefore, there is no need for spark plug anymore. So that's how the principle of a diesel engine works, no? So, but before we will be going to proceed to that, let us define first what is an air standard, no? So what is an air standard? So we discuss about an air standard auto cycle, air standard diesel cycle, but what is meant by the word air standard? Okay, so air standard has this particular assumptions, no? So in order to say that it is an air standard, it has this particular assumptions. So first assumption is the working fluid. So the fluid which is responsible for the transformation of heat to work, which is known as the working fluid, is generally air, for air standard, no? Which continuously circulates, which continuously circulates in a diesel loop, in a closed loop, sorry, in a closed loop, and always behave as an ideal gas. So when we say an ideal gas, it obeys the ideal gas law, which is the PV equals MRT. So an ideal gas obeys that equation, therefore that equation is true for an ideal gas, but in reality PV means MRT is also just an approximation, no? Because there are many changes in, there are many factors that affects like sudden change in temperature, sudden change in pressure. So assumingly the air is uh, an ideal gas, which is it is nearest to being an ideal gas. It's the gas that is nearest to being an ideal gas. So the working fluid is air, which continuously circulates in a closed loop and always behave like an ideal gas. This is the first assumption, no? Assumption na siya. Second assumption is that all processes that make up the cycle are internally reversible. So when we talk about all the processes that make up the cycles are internally reversible, it means that the cycle is occurring at an infinitesimally slow process, and the sudden expansion due to heat and friction is reduced, no, by slowly moving through the path of the process, no, so it's not abrupt. This is the assumptions for an air standard cycle, therefore isentropic. So third assumption, so but these are just assumptions, no, that the air is an ideal gas, that the processes are isentropic and reversible, meaning the process are occurring infinitesimally slow and there is no heat generation due to friction. Those are just assumption. Number three, the combustion process is replaced by a heat addition process. So the process which uh, denotes that there is combustion occurring is the QA addition, no? So in the QA addition, heat addition process. The same thing with the exhaust, no? So the exhaust process is also represented in the cycle via the QR, no? Or the heat rejection process. The exhaust process is replaced by a heat rejection process. So process. So an air standard, therefore, to summarize, an air standard assumption, first, it assumes that the working fluid is air and it obeys the ideal gas law or is an ideal gas. Second assumption is that the processes are reversible, therefore, the process occurs infinitesimally slow and there is no sudden heat friction, no, and sudden expansion of molecules due to sudden heating, therefore isentropic in nature. uh, Assumption number three is that a combustion process is replaced by the heat addition process, and while the process is replaced by the QR, no, or the heat rejection process. That is an air standard assumptions, no, air standard assumptions. Therefore, when they say about air standard diesel cycle, it follows those assumptions. So, this is a typical PV diagram of the diesel cycle. So, the diesel cycle, okay, if this is the point 0, then this is our, then we will draw an imaginary line to represent that this is our top dead center, no? Okay, so, and also an imaginary line to represent our bottom dead center, or the lowest position that a piston can travel. Top dead center is the highest position that a piston can travel. So here there is compression occurring from point 1 to point 2, no? Okay, so what happens is tuwang sa curve. So this is our point 1. This is the path of the compression process, which is isentropic. So this is the intake process. So if this is the piston, so this is the piston. So in the intake process, it moves like this. So intake, this is the first stroke, no? Intake, gikan diri to dira, no? Intake. Compress, dayon balik na sad, intake. Compress, piston moves from bottom dead center to top dead center. Then during this, the hot air is compressed and the air and fuel mixture is injected into the cylinder, therefore creating combustion, no? Which produces a combustion is a constant pressure process. Okay, then this is our point 3. Then expansion. So this is our compression stroke. So this is intake na compress, power stroke or combustion stroke, another arrow going backwards to bottom dead center. Then power. So this actually is what consists of power stroke. So 3, 4. Okay, this is also an isentropic expansion process. So technically, This whole process is the expansion process kutob diri. Gikan number 2 to number 4 are all part of the expansion process because intake, compress, combust, power stroke, exhaust. So exhaust is kinalasan, mubalik siya diri. So exhaust. So intake. So also with the auto, no, kung ang inyong remember ang auto ninyo. So if this is the so intake siya. So intake, first move, intake, compress, combust, power or combust. So meaning kini intake ana diha usa ka flow intake nya dayon gikan diri kana dinha mo ni siya diri compress mula ni napat siyang compression isentropic ana. So therefore there is combustion occurring here, power, so the power di ay gikan diri, so 1 2 3, so from 3 di ay to 4. Okay, 3 to 4 is the power stroke. So that is the power stroke. Then from point 1 back to origin, which is point 0, is the exhaust stroke. So 4-stroke engine. 4-stroke. The same, anisad, 4-stroke sana siya. So first is, again, intake, compress, combust, exhaust. Okay, so there are 4-stroke. The same sa diri sa inyohang auto, no, sa auto ini diesel. Okay, so intake, compress, intake, compress, diri compress ana, combust 3.1, exhaust dayon. Exhaust. So 4-stroke cycle. So in a diesel engine, the QA is added between 2 and 3, process 2 and 3. And QR is exited between 4 and 1. So this is the cyclic integral, or the area under this closed cycle, area under this closed cycle is what is known as the work net. Okay. So if we will be going to draw the TS of the diesel cycle, so this is the temperature and this is the entropy. So the pressure lines looks like this, no? So between point 1 we have a constant entropy compression, isentropic compression reaching to point 2. Then point 2 is a constant pressure process. This is a constant pressure line, which is the pressure high and the pressure low. So in the pressure high, nisubay aning linya kay constant pressure process man. So that this is where QA is introduced, no, in the power stroke. So after that, the expansion occurs from 3 to 4. So 3 to 4 this is a constant pressure process. 3 to 4 is a isentropic expansion process. Now, this from 4 to 1 is a constant volume. Okay, constant volume process. Okay, so this is the TS chart, TS diagram in TS chart of the diesel cycle. So again, this is the work net, the area under this closed cycle, under air standard assumptions. So, let us derive the formulas. So the QA is MCP T3 minus T2, no? And the QR is MCV times T4 minus T1. Okay, so work net is QA. So CP sa air ha, kay air standard ni. QA minus QR. Therefore, our thermal efficiency is what? Work net over QA, which is equal to T3 minus T2 quantity minus T4 minus T1 over T3 minus T2. So, kung inyo ni siyang i-manipulate, no, using the PTB relations of the gas processes, no, so you will find out based on the derivation, kay mga tigwang na mo, kamaon na mo ni. It is equal to 1 minus 1 over Rk to the power of k minus 1. You can memorize this, or technically in the designing there is a chart, so you don't need to memorize these things. But since you are not in the designing yet, you still need to pass the board exam. So either you derive this, which is a very lengthy process, or you either memorize this, which will make your time shorter. So this gikan ra na siya dinha using the processes, no, the the equations of the relations in relations to pressure, volume, and temperature, no, katong na mga K over K minus 1 or K minus 1 or K. So I assume you already memorized that so that you can derive these equations. So again, we have compression ratio, which is RK, compression ratio. So the compression ratio is the ratio between what? V1 and V2. Okay? So you know that V1 is Vc plus Vd over Vc, because V2 is equals to Vc. Therefore, the CVd plus Vd over Vd is equal to 1 plus C over C. Therefore, that is the other formula for compression ratio. Therefore, we know that Vc is equals to V2, therefore, based on this relationship. No. Therefore, Vd is also equal to V1 minus V2. So, therefore, from CVd is equals to V2, because this is Vc. Therefore, we could say that C is equals to V2 over Vd, which is equals to V2 over V1 minus V2. So, in the diesel cycle, there is also what is known as the cut-off ratio, RC, known as the cut-off ratio. And cut-off ratio is equal to the ratio of V3 over V2. Okay, this portion here, the cycle. Yeah, the ratio of V3 and V2. V3 and V2. So, kung imo ning i-ratio ang V3 to V2, that is now the cut-off ratio. That is where cut-off ratio occurs. Therefore, we can now proceed to the dual cycle. So, dual cycle is a theoretical engine that combines, if there is a fuel that that has a property in between a gasoline and a diesel fuel, then this is the engine you need to use. So, to define air standard dual cycle is an ideal cycle that, so after this discussion, I will present to you the chart in which, based on the compression ratio or the compression ratio of Otto cycle, we can now predict the efficiency, no, the thermal efficiency of the engine. So technically, in the design there is a chart, no, but for you who needs to take the board exam, It's either you derive the efficiency equation katong using RK, or for diesel using RK and RC, for kanang dual cycle is NIRP. So you can derive or you can memorize, no, which is the shorter and easier path, no, that approximate the performance of a spark ignition internal combustion engine and is a combination. So the thing here, the idea is it is a combination of a diesel and gasoline method of producing power, no? Combination of diesel and Otto cycle. Okay, so the heat is added in both the constant volume and constant pressure process. So what does this mean? So let us draw the PV diagram of the dual cycle. Okay, so this is the dual cycle. This is your TDC, your B2. This is your B1. So from here, of course, we have the intake stroke, point 0. Okay, so then we compress to point 2. Okay, we compress to point 2. So intake, compress. Then there is spark plug ignition that occurs between point 2 and point 3. Therefore, there is QA sub 1 here. Okay. Then between 3 to 4, there is a combustion due to compression. We have QA2 between 3 and process 3 and point 3 and 4. Then this process here is, of course, constant volume process. This is constant entropy process, constant pressure process, and then it expands isentropically back to B1, no, which is now 0.5. Okay, so we have 5 points for a dual cycle, and there are two QA process, which is one in the constant volume and the other one occurs at the constant pressure process. So the trick in the dual cycle is you need to sum first the total QA, no, which is QA sub 1 plus QA sub 2. So therefore, the equation, TS pa yan, TS. This is the TS. So the TS, this is the two pressure lines. This is 1, 2, then constant volume man, so musayo paubos. This is 3, then ang constant pressure musubay. This is 4, it expands to 0.5. Balik sa constant volume ni paana ni. Okay, so this is constant entropy process, constant volume process, constant pressure process, constant entropy process, and constant volume process. So QA is added here, QA1 and QA2 is added here, and QR is rejected here between 5 and 1. Now let us write down the equations for dual cycle. QA is equal to MCV times T3 minus T2 plus MCP times T4 minus T3. Okay, then we have QR equal to MCV times T5 minus T1. So in worknet, we have QA minus QR. So efficiency is work net over QA. This is equal to QA minus QR over QA. So, we could also derive, kung valuehanin ninyo diri og mga temperatures, we can also derive efficiency to be 1 minus 1 over RK to the power of K minus 1 times RP times RC K minus 1 over K times RP quantity RC minus 1 plus RP minus 1. So during our time, we memorize this thing so that we will just have a direct substitution if we are given with RP, RC, and RK. No? So, but you could derive this gikan diri, no? Gikan diri, muagi mo din ha. Gikan din ha, maabot mo din ha. So, we have again compression ratio to be equal to B1 over B2, no? B1 over B2, which is again equal to 1 plus C over C. Okay, so we have RC. Our RC in this process, or the cut-off ratio, occurs between point B4 in ratio to B3, no? So therefore, this is RC is B4 over B3, and we also have what is known as the pressure ratio. So tulo na. Compression ratio, cut-off ratio, and pressure ratio. So pressure ratio RP is equal to P3 over P2. Kini nga dapit. The ratio of pressure between mo na pressure lines, na din ha dapita. Ang ratio aning P3 to ang sa pangalan ni P2 is pressure ratio RP. Okay, RP na siya. Ang ratio ani. No? So, okay, so if na mo aning RK, RC o RP, makuha ninyo ang cycle thermal efficiency. So, that's it for our diesel and dual cycle. So, we will have sample problems next meeting. Oh no, I will present first the chart for I will present the chart. So para dili ka mag-memorize atong katong tag-as kayong na mga RQ o RC, aw kani sa auto man siya. So ang auto ara ra ka kaning na curve, no, kaning pink. So kining pink, K equals to 1.4, this represents for air. Kung 1.3, this is lain-lain sa nga gas. Ang 1.667 carbon dioxide. Basta gas, air standard man ta rita sa air 1.4. So kining 1.4 di ay as magkataas ang iyang compression ratio to 12, ang iyang efficiency sad magkaduol or magkalapas sa 0.6. So ang 12 nga compression ratio kay maabot ta kag mga 60 something percent nga thermal efficiency. But if you look at the graph, nigmaabot ta siya 60, bisag pasakaan pa nimong compression ratio diri, mo asymptotic na imong graph. So the more higher the compression ratio, the more higher is the power need, no? So meaning kanang dili na practical kung imo pang patason og kumayo ang compression ratio. Pwede siguro mga 13, 14, 15, but above na kaayo dili na siya mo matter kay if you look at the graph and you try to interpolate or extrapolate, the graph will become a flat graph, no? So therefore bisag pila pa imong i-add nga compression ratio, which is you will consume energy, the efficiency will remain with less difference. So therefore practically Otto cycle is at best at 12, 13, 14 or 15. No? So if we will look at also in the diesel cycle, there is this is for air, no, which is RK is 1.4. Oh no, the K is 1.4, no. So here we could say that given with the same compression ratio, so no, given with the same K, which is air, no, 1.4, and this is the compression ratio. So awan naabot og 22 ang iyang compression ratio. Ang pinakataas di ay ang O2, no, which is kung iwanin nimo ang RC mahimong O2 ang imong formula sa imong, kung mawani ang RC ba ang imong formula sa imong efficiency mahimong the same sa Otto cycle, which is 1 minus 1 over RK to the power of K minus 1. So therefore kung Otto siya di ay kung RC is equals to 1, therefore it's also where the highest efficiency occurs, no, when the cycle looks like an Otto, no, at higher compression ratio. But in diesel cycle na atas mga 2, 3, 4, no, so 2, 3, 4 dili man ta Otto, diesel man ta. So 2, 3, 4 mo reduce sad, so ang 2 mo pinakanindot, no, na saka sa mga 18 nga compression ratio nya naka sa 2 nga cut off ratio. Therefore mo attain ka sa highest nga efficiency sa diesel, but it is lesser than sa auto, no. Ang auto joy higher efficiency kontra sa diesel at the same compression ratio, no. Okay, so this is the between 12 to 23 is the typical compression ratios for diesel engine. 12 to 23, while in the auto cycle 12, 14, 15, no. This is size. Okay. So pero ang diesel na 12 to 23. So taas jud ang compression ratio sa diesel, no. Of course, it needs the heat of compression in order to ignite. This is for auto and diesel cycle only, no. So sa dual ato pa nang pangitag chart, but technically it looks like this. So that ends our discussion on diesel and dual. So we will have sample problem discussion next meeting. Thank you very much and good day.